So back in chapter 1, one of the things we talked about was how do you solve two-step equations. You already did some practice with that in the previous section. But one of the things I told you is if we're solving an equation like, say, 3x plus 9 equals 6, you always want to get your like terms together, so you want to always do your addition and subtraction first, which is true. We always want to, which is true, it definitely always works. You can take this 9, subtract it from over here, 6 minus 9 is negative 3, so you get divide both sides by 3, then you get x equals negative 1. That certainly works, but in this video, one thing we're going to do is I'm going to show you a little trick that will help you, mainly it'll help you with when you're dealing with equations with fractions. But it certainly works for all equations as well. The main reason I told you guys to make sure that you always get rid of this 9 first is because a lot of you, whenever you divided first, you would do one of these. Okay? So what you were doing was you were dividing part of the left side of the equation, but you weren't dividing the whole thing by 3. Okay, so really what we wanted to do is extend this division bar underneath everything. So what that basically means is this. That basically means that if you want to divide first, which you can, that's fine, but you have to divide every term by that coefficient by 3. So this then would become, and remember we said if we subtract 9 and then divide by 3, here we're going to subtract 3 and then we're going to divide by 3 and then subtract. So if we do it the traditional way, we got negative 1. So watch what happens when I do this. 3x's divided by 3 would be 1x. 9 divided by 3 is 3. 6 divided by 3 is 2. Then, if I subtract 3, notice I still get x equals negative 1. So it still works. It shows basically what I'm doing is I'm taking my 3x plus 9, this entire term here, and I'm factoring out. I've noticed they both have factors of 3 here. I'm making that a little bit easier. This works for everything. It's a little bit more tricky with some things. Like for instance, let's say this was 3x plus 7 equals 6. Well, now when I divide by 3, I get x plus, whoops, here's the problem, 7/3 equals 2, which we can definitely do. I mean, get common denominators. So here, this is 2 over 1, this is 7 over 3, so multiply this by 3 to get 6 over 3, and then subtract 7/3 from both sides. So it's doable, it certainly works, but sometimes it's just easier to maybe subtract 7 and get 3x equals negative 1, and then your answer is negative 1/3. Same thing, same answer, but it's kind of up to you how you want to do that. So let's take a look at a little bit more useful. So let's take a look at the equation y divided by 2 minus 3y over 8, so 3/8 y, plus 1/4 equals 1/2. Okay, so this is y divided by 2 minus 3/8 y, so 1/2 y minus 3/8 y plus 1/4 equals 1/2. Now, you could have solved an equation like this back in chapter 3. You could have, gotten common denominators here. So common denominators between 2, 8, 4, and 2 is 8. So we would multiply this by 4 and this by 4. We'd multiply this by 2 and this by 2 and this by 4 and this by 4. And we get 4y over 8 minus 3y over 8 plus 1/8 equals 4/8. So, and then we can combine like terms and solve it. Let's do something a little bit differently. Basically, we're going to kind of use what we talked about in the last example. But what I'm going to do is I'm going to multiply everything by something that's going to get rid of all these denominators. This is a trick called clearing the denominator. So notice, if I were to multiply, let's take this term right here, this 3y over 8. If I were to multiply this by 8 over 1, or just by 8, notice what happens. This 3y stays here because 3y and 1 can't cancel, but notice the 8's here. I can simplify this. I can change that to a 1 and that to a 1, and then this term becomes 3y. So I just got rid of my denominator here. Now, the only issue is that if I multiply one of these terms by 8 over 1, I have to multiply everything by 8 over 1, or else this right here, this equal sign, is no longer true. So I'm going to multiply this by 8 over 1, and notice what happens. Okay, the 2 cancels, and then when I do 8 divided by 2, I get 4. So 4 times y is 4y. So I have 4y minus 3y, and then this one is times 8 over 1, and then simplify, plus 2 equals, and then this also has to be multiplied by 8 over 1. Notice every term is getting multiplied by this 8 over 1. That way I'm making sure everything stays the same. So we'll simplify this, and this equals 4. Now, all I have to do is combine like terms. Notice the 4y and the 3y, this is a like term, and the 2 and the 4 is a like term. So let's put these y's together. 4y minus 3y is 1y plus 2 equals 4. And now we'll just subtract 2 from both sides. And we get y equals 2. So notice how clearing the denominator, multiplying by something that will clear out everything down here, makes it a little bit easier because we don't necessarily have to work with fractions. That's just a little trick that will help you. And it's not always that cut and dry, and you don't always have to use this. And definitely get all common denominators and just work with fractions. Sometimes that's just as easy. Let's take a look at another example here. That last one was pretty easy because everything went into 8 very simply. So let's take a look at 2p over 3 plus p over 4. So that's 1/4 p. Read this as 1/4 p. This is 1/4 p. Read this as 2/3 p. Okay. Minus 1/6 equals 7/2. So here's the issue. 4 and 6. 4 doesn't go into 6. So I have to find a number that all these numbers will go into. We call this is a term you have heard before, the least common multiple. So if I just take these numbers, I could just take these numbers and multiply them all together. That would give me a multiple of all the numbers. It would give me a very big multiple. Or I can start to think about which number would work here. One thing that pops out at me, if I take this 6 and multiply by 2, I get 12. So they all go into 12. So I'm going to multiply everything by 12 over 1. And let's see what happens here when I clear the denominator. So when I multiply by 12 over 1, this 3 cancels, and 12 divided by 3 is 4. So 4 times 2p, 4 groups of 2p is 8p. We'll multiply this by 12 over 1. And then 12 divided by 4 is 3. So plus 3p. And this is times 12 over 1. 1/6 times 12. This becomes 1. This becomes 2. Minus 2 equals 12 over 1. Cancel. Cancel. And this becomes 42. 7 times 6. Right there. 7 times 6 is 42. Okay. So next, we've got to combine like terms. I'm going to take this 8p and 3p, that's 11p, minus 2 equals 42. Look how easy the problem becomes. As soon as we get rid of those denominators, I don't have to deal with the fractions there. Again, nothing wrong with dealing with fractions. I could have gone up here and multiplied this times 3, and this times 3, multiply this times 2, and this times 2, get 12 in all the denominators. But instead of getting 12 in all the denominators and working with common denominators, I multiplied by 12, and that cleared out all the denominators for me and kept the equation the same. So I'm going to add 2 to both sides, and I get 11p equals 44. Divide both sides by 11, and p equals 4. Like I said, you're not going to need to use this on every single problem. This trick, this clearing the denominator, obviously is useful when you have a denominator. So go ahead and try the problems below here, and let me know if you have any questions.